My name is Sandy Copeland. I am an adjunct assistant professor in the Department of Anthropology at the University of Colorado Boulder. We were interested in how early hominids moved about the landscape, in part so we could learn something more about their social structure, or maybe their diet, or other aspects of their lifestyle that are difficult to discern from just the bones themselves. We decided to apply a method known as strontium isotope analysis, and we applied this to 19 early hominid individuals that lived around 2 million years ago in South Africa. The strontium that's in tooth enamel can provide evidence of where an individual lived when its tooth was forming. We analyzed teeth from 2 different hominid species. 8 were Australopithecus africanus, and 11 were Paranthropus robustus. We wouldn't have been surprised to find that there were differences in landscape use patterns between these 2 different hominid species. We found evidence that many of the individuals might have actually grown up on the local dolomite bedrock. Among the large individuals, the probable males, only 11% of them showed evidence for coming from a different geology than that of the cave site where they eventually died. Among the small individuals, the probable females, at least 50% of them were not from the local dolomite. The most parsimonious explanation for this is that it had to do with the dispersal pattern of those hominid species. In other words, it was probably the females that left their natal group.
This potentially tells us something fairly significant about social structure, and certainly tells us something about how males and females differentially utilize the landscape. One of the difficulties is people often don't recognize today that there are real controversies about the ecology of modern animals. So if it's difficult enough to tell us everything we want to know about animals that we can just go out in the landscape and look at, you can imagine how much more difficult it is when we're looking at things at a couple of million years removed. And that's where modern technology has really aided us in a variety of ways. And this study is one example of that.
Our study provides the first direct evidence for the dispersal patterns of early hominids. Other scientists had predicted that early hominids would be characterized by a female dispersal pattern because that's what we find in our closest relatives, chimpanzees.